Welcome. This video will be about piecewise functions. Piecewise function is where a function is compiled of two or more different functions. The domain of each function determines the final function. The domain of each function cannot overlap with any other domain unless the resulting values are the same. For the following function h of x, we have three different functions involved. Negative 3x minus 18 for when x is less than negative 5. 1 for when x is between negative 5 and 1. And x plus 2 when x is greater than or equal to 1. For the given function h of x, the negative 3x minus 18 has a domain where x has to be less than negative 5. Therefore, the domain will be from negative infinity up to negative 5, not including. For the second function 1, it exists between negative 5 and positive 1, including the negative 5 because of the less than or equal to, but not including the 1 because it's strictly less than. And for the function x plus 2, that function exists only when x is greater than or equal to 1, so it's going to be bracket 1 to infinity. All three functions are linear functions in this problem. We can tell which interval of the function is either increasing, decreasing, or constant by identifying the slope. So for the first function, negative 3x minus 18, because the slope is negative 3, this is decreasing throughout its domain. For the function 1, it has a slope of 0, so it is constant throughout its domain. Notice that it did not bracket the negative 5 because when it comes to increasing, decreasing, and constant, it is an open interval, therefore we cannot include the endpoints. And for the function x plus 2, it has a slope of 1, therefore it is increasing throughout its whole domain. For each piecewise function, find the specified function value. For f of x is equal to negative 5x minus 8, that exists only when x is less than negative 2. For the second function, 1 half x plus 5 exists for negative 2 is less than or equal to x, less than or equal to 4. And for the third part of the function, 10 minus 2x exists when x is greater than 4. Therefore, the domain for each will have the first function has a domain of negative infinity up to negative 2. The second function will have a domain of negative 2 to positive 4. And the third domain is going to be from 4 to infinity. In order to evaluate the function of a piecewise function, you need to first identify what value you want to evaluate at, and then determine what function you need to apply it to. For the function f of negative 4, we need to realize that x is equal to negative 4. And we need to find out what domain does negative 4 fall into. It falls into the first one. So we're going to take the negative 4 and plug it into the first equation. And we will get an answer of 12. For f of negative 2, we need to realize that x is negative 2 in this scenario. And we need to find out where does negative 2 fall into. It falls into the second function because x is equal to negative 2 on the second function. Therefore, 1 half times negative 2 plus 5 is the equation or function you want to evaluate negative 2 at. For the function f of 4, that's telling me that x is equal to 4. And I need to find out what domain 4 falls into. It falls into the second equation, or second function, because x is less than or equal to 4 on the second line. So 1 half times 4 plus 5 will give you an outcome of positive 7. And for f of 6, we need to realize that x is equal to 6, and that will fall into the third function, because x is greater than 4 in the third function. Next, we want to make a hand-drawn graph of each of the following. Check your results by using a graphing calculator. For the function f of x, it has two parts, where the first function is negative 1/3 x plus 2 exists when x is less than or equal to 0. The second function, x minus 5, exists when x is greater than 0. So in terms of the domain of the first function will be from negative infinity up to 0. And the domain of the second function is going to be from 0 to infinity. Notice that for each function, they're linear because both x's are to the first power. Therefore, it only takes 2 points to make a straight line. So for the first function, we always want to pick two numbers that are in the domain in order to graph a straight line. We always do it endpoint no matter if we include it or not. So I need to pick two values that are less than or equal to 0, and one of them needs to be 0. So 0 is one number. And a little mathematical trick here is the fact that if you have a number in front of the variable that's a fraction, then pick a number that's a multiple of that denominator. So what is a number that is less than 0 that's a multiple of 3? Negative 3. If I plug in negative 3 into that first function, I'm going to get positive 3. And if I plugged in 0 into that function, I will get positive 2. One important thing to know about this piecewise function is that you're going to have starting points and ending points. And on the starting and ending points, you need to understand when are the endpoints going to be open or not including, and when is it going to be closed, which is including. In problem number 1, when you have a domain that's including 0, that means that at 0, 2, it's going to be a closed circle. That's going to go through the other point of negative 3, 3. For the second function, I need to pick two values that are greater than 0, but one of them needs to be 0. And I can pick any other number greater than 0, and I'm going to pick 1. Plug that into the function. And one thing to realize about the second part is the fact that the domain of the second function is not including 0. Therefore, we're going to have an open circle at 0, negative 5. So let's put this on a graph. So first, let's take a look at the first function. I have the points negative 3, 3. And 0, 2. And that 0, 2 is a closed circle. And I'm not going to go past the y-axis. For the second function, I have the ordered pair of 0, negative 5. That's an open circle. It's going to go through the point 1, negative 4. And it's going to go on forever. Notice that on the y-axis, I do not have two closed circles, because that means it would not be a function. And make sure that you put arrows at the end of your graphs to represent that they continue on forever. Let's take a look at the next function. It has three parts to it. 4 for when x is less than or equal to negative 2. X plus 1 for when negative 2 is less than x is less than 3. And negative x for when x is greater than or equal to 3. The restriction that the function has really tells you what your domain is. For the first function, your domain is going to be from negative infinity up to negative 2. Your second one of x plus 1 is going to be from negative 2 to positive 3. And for negative x, it's going to be from 3 to infinity. In terms of graphing this piecewise function, notice that all three functions are linear. I like to label my functions. For the first function, I need to pick 2 points that are less than or equal to negative 2, and negative 2 needs to be one of them. So I'll pick negative 2, and a number less than that would be negative 3. And in both cases, it doesn't matter what x is, y value is going to be 4 in both cases. Because the domain includes the negative 2, at negative 2, 4 is going to be a closed circle. For the next function that exists between negative 2 and positive 3, because it has a starting point and an ending point, those are the 2 points that we're going to use for the graph. We're going to start at negative 2, and we're going to end at positive 3. And since both of them are not including, they're both going to be open circles. And for the third function of f of x being equal to negative x, need to pick a value that is greater than or equal to 3, and one of them has to be 3. A number greater than 3 would be 4. Plug that into the function, I get negative 3 and negative 4. And because the domain of the third function includes the 3, I'm going to have a closed circle at 3, negative 3. Since 2 points make a straight line, let's graph it. First one I have is negative 2, 4. And negative 3, 4. It is a constant function going to the left. The middle part, I have an open circle at negative 2, negative 1. And at 3, 4. And for the third function, I have an ordered pair at 3, negative 3. Closed. And it's going through the point 4, negative 4.